All right, moving into our next unit. Starting off here looking at triangle sum and exterior angle theorems. Warm up just solving for x. Now you'll notice all of these equations are set equal to 180, which is going to be a key here coming up in a minute. I'm going to solve the first two, then leave the second two for you to try. But I'll give you the answers so you can check your work. So for number one here, we just got one step. Subtract 105, and we get x equals 75. For the second one, 2x plus 65 equals 180. We're going to have two steps. We've got to subtract over our 65. You'll get 2x equals, let's see, 115. And then we'll divide by 2. And that'll give us x equals 57.5. Okay, for 3, you should get 37.5. And for 4, you should get 45. All right, so key terms we're going to be looking at: triangle sum theorem, exterior angles of a polygon, what those mean, remote interior angles, and exterior angle theorem. All right, we're going to skip on past the getting started activity. That's something we'll do in class with some patty paper. So we're going to move on down to this page with activity 1.1. Like it mentions in that activity that we'll do in class, you notice about the relationship between three angles of a triangle. It's called the triangle sum theorem. That theorem states that all angles of a triangle add up to be 180. The sum of those angles add up to be 180. So just looking at some examples here, it says Trevor's organizing a bike race called the Tri-Cities Criteriums. Criteriums consists of several laps around a closed circuit. Based on the city map provided to him, Trevor designs 3 different triangular circuits and presents scale drawings of them to the Tri-Cities Cycling Association for consideration. So classify each circuit according to the type of triangle. Well, looking at the first one there, circuit 1, he's got it labeled as. We got a right angle listed there. So that is a right triangle. Second one, we got an angle that has a measure of 112 and an angle of 120, but we don't know that third angle. But that first one here, the first angle I mentioned is 112, larger than 90, so that is an obtuse triangle. And then the third one, all 3 angles are under 90. This is acute. So 2 says use triangle sum theorem to determine the measure of the third angle. So for instance, with circuit 1, we have 90 plus 50. And we need it to add to that to get to 180. Well, if you solve that, you're going to discover that that third angle is 40 degrees. For the second one, we got angles of 112 and 25. So we got to find a third angle to add to that to be 180. And if we solve for x there, you're going to find that it is 43. And I'm going to skip down and use this space down here for number 3. Triangle 3, we have angles of 70 and 50. So those add to be 120. We need another angle to get to 180, and that will be 60 degrees. So there's my 3 missing angles for triangles 1, 2, circuits 1, 2, 3, those triangles there. All right, measuring side lengths. We're not going to actually measure them, but we're going to talk about the rule that we know. So first, angle measures. We're going to identify those. So for number 4, list the angle measures from least to greatest. So for the first one, least to greatest would be 40, 50, and then 90. For the second one, we'd have 25, 43, and 112. And for the third one, we would have 50, 60, and 70. Okay, the side lengths, looking at the side lengths. The key here is the smallest angle, the side across from that will be the shortest side length. That corresponds to it. So for instance, on triangle 1, I'm going to go up here and draw some lines here. We identified this angle was 40. 40 is the smallest angle there, so the side across from that would be the shortest. So this would be the shortest. Across from 50 would be the second shortest, and then across from 90, the largest angle would be the biggest side length of that triangle. So C, describe what you notice about the location. It's what we were just talking about. The shortest side is across from smallest angle. Okay, D is the opposite. What do you notice about the location of the angle with the greatest measure? So the largest side is across from the angle with the biggest measure. So 5, Tracy, the president of the Tri-City Cycling Association, presents a fourth circuit. The measure of the two interior angles of the triangle are 57 and 61. Determine the measure of the third angle, then describe the location of each side with respect to the measure of the opposite interior angle. Okay, well, the measure of the third angle, if we have 57 and 61, the third angle we would have to add to that to get to 180 would be 118. So there's our third angle. So we got three angles of 57, 61, and 118. So the longest side, oh, sorry, I made a mistake here. 118, let's go back up a little bit. I got ahead of myself. 118 is the addition of 57. Let me explain my mistake here. 118. So to add to 118 to get to 180, we're at 62. My fault. So 62 degrees is our third angle. So our longest side is going to be across from the largest angle, which is 62 degrees. So the longest side is going to be across from angle that's 62 degrees. And the shortest side is going to be across from our smallest angle, which is the one that's 57 degrees. So angle that's 57 degrees. So if we take a look at 6 here, if we just want to list the side lengths from shortest to longest, well, if we identify the third angle here, adding to be 180, 47 plus 35, the other side would need to be 98. So shortest to longest side on that diagram, shortest would be X. Second longest or second shortest would be 2, or the Z, and then here's our longest side across from 98. For B, the missing angle, if we had 52 and 81 to get to 180, it would be 47 degrees. Those would add to be 180. So our shortest side would be P across from the 47. Next shortest would be across from the 52, side N. Then our longest side would be side M. All right, and then C, finding our missing angles. So for that smaller triangle, we got a 38 and 50. So if we add those together, the third angle to get to 180 would be 92. And for the other triangle, 50 plus 45, the third angle to add to be 180 would be 85. So we're just adding up to be 85 or 180 on our interior angles. Now putting those in order from smallest to biggest, I'll do the triangles separately. So first, the bigger triangle, shortest would be side G. We'll call this triangle 1, triangle 2. So G and then H and then D, just across from the angles that correspond to the smallest angle to the biggest angle. And then for the smaller triangle, the shortest side would be F across from 38 degrees, then E across from 50, and then G across from 92. So you notice on one, G is the smallest, on the other, G is the biggest, just due to the size of the triangles. All right, so moving on to activity 1.2, looking at what's now called the exterior angle of a polygon. So if you look at that triangle, you see angles 1, 2, and 3 identified. Angle 4 is the angle just outside that side that connects 1 and 3. Now, when you continue that side length, what that does is creates an exterior angle that's against angle 3 there. Those two angles, 3 and 4, add together. You can tell by they create a straight line, add together to create 180 degrees. So the conjecture we can make about angle 3 and 4, since they create a straight line, they add to be 180. Now, keeping that in mind, we know that angle 3 plus angle 1 plus angle 2 also add to be 180. So what that tells us is that angle 4 is equal to the sum of angle 1 and angle 2. Okay, so there we can add those together and also get to 180. Okay, so moving on, we're going to investigate that a little bit. Kind of just diagrammed out what A is asking. What does measure of angle 1 plus measure of angle 2 plus measure of angle 3 equal? Well, those are the interior angles of the triangle, so those add to be 180. And then B, what is the measure of angle 3 and angle 4 equal to? Also what I just diagrammed out above, those add to be 180. So the relationship between 1 and 2 and 4 is that they are equal to each other. They both have to add to be equal to each other. So angle 1 plus angle 2 has to be equal to angle 4. Since we know that 1 and 2 combined with 3 equal 180, and we know that 4 combined with 3 equals 180. So that means 1 and 2 combined together have to equal to angle 4. All right, so we're going to use that a little bit. So in a triangle, each exterior angle, there are 2 remote interior angles. So that's what we were just looking at. So looking at that triangle, for this exterior angle of angle 4, 1 and 2 are the remote interior angles. So they're the farthest angles away from that exterior angle that are on the inside of the triangle, which is explaining what A is asking. Why would 1 and 2 be referred to as remote interior? They're the 2 interior angles furthest from the exterior angle. The exterior angle we've identified. Okay, for B, you could try that on your own. Just extend another side out, label the exterior angle 5, then identify the 2 remote. If you want to pause it and try that, you can. I will do that here. I'll make one. I'm going to use green. I'm going to make this side between 1 and 2 extend out. I'll call that 5. So the remote interior angles for angle 5 would then be 1 and 3. All right, so the remote interior angles of a triangle are the 2 angles that are non-adjacent to the specific exterior angle. That's what we were just mentioning. So rewrite measure of angle 4 equals the measure of angle 1 plus the measure of angle 2 using terms such as sum remote interior angles. Okay, we just did that above. We will do it one more time. So the sum of angle 1 and angle 2 equals angle 4. All right, on to the next page. The original diagram was drawn as an obtuse triangle with 1 exterior angle. If the triangle has been drawn as an acute or right triangle, would this have changed the relationship? No. This relationship applies to all triangles. Fix that letter P there, got a little messed up. This relationship applies to all triangles. Okay, so using this theorem now that we know, the exterior angle theorem, looking at A here, X has to be equal to the sum of 21 and 32. And if you add those together, you'll find that that's 153. We can do that for each one of these triangles now. So for instance, on B, we're given the exterior and one of the remote interior. So we know that 16 plus x, these two, have to be equal to 143. So if we solve for x and subtract 16, we are going to get that x equals 127 degrees. And very similar on C. We know that 93 is equal to x plus 31, the two interior angles added together. So again, if we solve for x, we're going to find that x equals 62 degrees. So we can use the exterior angle theorem to find those angles in both the remote interior given the out exterior or vice versa. Okay, for 7, continuing also same type of examples. We know on 7, 108 plus x has to equal 156. So again, we can subtract 108 and solve for x there, and we get that missing angle x is 48 degrees. Okay, I would pause and try the last 3, unpause, and then see what your answers, if they match up what I am getting. Okay, B is a little different. We got x plus x, which would give us 2x equals 152. So our one step to solve this is going to be slightly different. We're going to divide by 2, and that gives us 76 degrees. Okay, if you move down to C, a little bit harder equation again to solve. We got 3x plus 48 equals 120 when we add those two remote interiors. So we got 2 steps to solve this equation. We're going to subtract 48, which gives us 72, and then we're going to divide by 3. And we will find that x is equal to 24. And then for D, hardest equation yet we're going to look at, we got 2x plus 6 is one angle, plus 40 is the other interior, remote interior angle, equals to our exterior angle, 126. So we'll first combine like terms, and then subtract the 46 over, solving for x. So 126 minus 46 gives us 80, and then divide by 2. And we will find that x is equal to 40 degrees using our exterior angle sum theorem. All right, ending up, talk the talk. There's 2 activities here. Number 1, we'll talk about that one. We will skip number 2. I would encourage you to pause it and see if you can try to find the missing angles that are given there using the rules we just know, and then unpause it and see if it matches up with what I am about to list out here. Okay, so looking at these triangles, I can tell first of all that this angle here, just using triangle sum theory, adding those up, 27 plus 26 to get to 180, this would be 127. We could use the same idea here. 46 plus 35 to get to 180, we would need to be 99. Now to get this angle, we can use something a little different we didn't quite talk about, but angles in a circle all the way around is 360 degrees. Well, we now know that 35, that other angle there, plus 127 plus 99, we're only missing one angle there to get to 360. So if we add all those up, we would need to get another 99 to get to 360. Now, using that, we can look over here at our this angle right here. And if we use what we know about our other 2 angles here, we're going to be able to find that this one is 36. And then our angle here should be 45. And we found this one's 10 up here. And our missing angle here, we know this creates a line. So that this angle is 135, and then our missing angle here, you should have found that it is 45 degrees. And then the last one we haven't identified yet, if we know that's 45 and 114 to get to 180, this angle would be 21 degrees. So just a little activity there, finding all the missing angles. see if what you found matches up to be those.